Hey there, you science people. I need a pen. There's my pen. Okay, let's get the science going. Worksheet 3.1. Notes. Oh, is my microphone turned off? Let's see. Oh, it's going. It's chomping at the bit. Okay. Here we go. Science, biomolecule, worksheet 3.1. Some review. I put these things here on purpose, very intentional, because we are going to start talking about monomers that are shaped like a hexagon. Look at this. Chicka-chow, ka-chicka-chow, cow, ka-chicka-chow, ka-chicka-chow. That's a hexagon. 6. Hexa 6. That sucker right there is glucose. And it's a molecule, just like this thing is a molecule. And monomers, that's a monomer. Monomers are molecules. So this, this isn't actually a real monomer, but this is a carbon, this is a carbon, this is a carbon, okay? This is a monomer, or this is a monomer of 3 carbons. That doesn't really happen in nature. But if you made a polymer of it, it would look like that, okay? So, circle some words here, okay? I mentioned this is a molecule of glucose. This is a molecule of water, okay? So you learned that last time. One more thing, catabolic. Catabolic, this is building, catabolic, breaking down, okay? So catabolic, okay? So there's some review of some things that we're going to see more of over here. And looking over here, I know there was some other reason I chose catabolic to be in there. I don't know. It's going to show up more later. Okay, let me pick something hard for you. What can I help you with? Chemical, energy output, law of conservation of energy, electrons, energy input. These are all pretty easy, actually. Okay, so something can cause something to move. In theory, in principle, energy causes things to move. Okay, so one more thing. The only time you can see energy is when it's being transferred. So like when you look at this soccer ball here, you don't see energy. But compared to this soccer ball, this one has more energy, okay? And so it's when its energy is being transferred from potential energy to what we call kinetic energy. That's when you can actually see the energy. You see the motion that it can cause. So it's during transfer, the time when you can see energy, it's in the transfer from one form to another that you can see energy. I don't even know if that's really a scientifically true statement, but it's what we tell kids. All right, so let's move on. This gets a little more complicated over here. It says circle which has the most potential energy. Okay, which of these two situations has the most potential energy? Or, I mean, we are so used to this idea that we have trained like 4-year-olds to understand this one. Oh, this is when the battery's fully charged. Speaking of almost dead batteries, look at my cell phone right now. Ah! Oh no, panic. I am like about to die right here, okay? I'm about to lose it all. Okay, and circle which has the most PE, and I guarantee some of my students are going to do this wrong. The correct type. Circle what type this is. Is this elastic energy? No. Is this gravitational energy? No, it's chemical energy. It's really electrical energy, but electricity is actually a storage of ions in 2 different compartments and then electrons flowing between them. So that's chemistry. Okay, let's do a hard one. They're all easy. Let's do one more. I really like this poop that I drew. That's probably the best poop I've ever drawn. Also the only poop I've ever drawn. This one's confusing and it wasn't in my thing, I don't think. What is that wrinkly thing? It's not a poop. It's a deflated balloon. Okay, balloons are stretchy. Another word for stretchy, elastic. This is a form of elastic energy. And remember, it says circle which has the most potential energy. Which one of these has more potential energy? This one. It can make the balloon fly around the room. Okay, so you're going to circle 2 things in every box. All right, keep moving. Now it's going to get crazy sophisticated. What in the science is going on here? Okay, complete the energy cycles with the words provided. Okay, it's the same things that you just saw over here, these ideas. One of these things has more energy, one of them has less. Okay, maybe I'll do one more over here. Okay, this is lower energy, this is higher energy. This has more energy in it because it has more chemical bonds. Okay, this is a form of chemical energy. Polymers are more chemically bonded than monomers, and so they have a little more chemical energy. Okay, so take this idea over here, okay, and let's do a hard one first. Now let's do an easy one first. We did the deflated balloon. Okay, so here's a deflated balloon. Okay, deflated balloon. You're gonna have to write like 25 words. Oh my gosh. Mr. Olgers, I'm a middle schooler. I don't write words. That's what middle schoolers are like. Balloon. 2 L's, 2 O's. That's a weird word to spell. So here's a deflated balloon. Now here's the thing about a deflated balloon. It has less energy than an inflated balloon. To get a deflated balloon to be full of energy, you have to use a bunch of energy. You have to use energy from your diaphragm. There's a muscle right here. And in order to inhale air, you have to contract this muscle. The muscle goes down, and then you actually relax, and the air comes out. So it's actually the downward contraction of a muscle that causes air to go into your lungs. And then you use that muscular contraction that is energy happening inside of you, your exercising muscle, and you can use it to push air into a balloon, and it inflates the balloon. Inflated balloon. And here's some more science. If you do it too much, you actually get rid of all of the carbon dioxide in your bloodstream, and the level of carbon dioxide in your bloodstream goes down, 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 and the level of oxygen in your bloodstream goes up, 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 and eventually you're like, I don't feel normal. Ooh, plunk. And you can actually pass out from having too little carbon dioxide in your bloodstream. That's an interesting problem. Okay, don't do that. It's bad for you. Here we go. So, inflated balloon is a higher energy state. It has more potential energy. It has more elastic potential energy. And then, when the inflated balloon, you let go of it and it flies all around the room, and it's like, right? And it goes back to a lower energy state. Okay? You can cross these off. Done. Okay, you have to do this with every one of these. This is going to take you 10 minutes. Okay, here's monomers in a polymer. I just put it on there twice just to make you really do it well. Okay, so monomers, the big picture, the lesson that you are really trying to learn today is that monomers are the low energy state, polymers are the high energy state. Okay, boom, boom. Actually, just be one polymer for every group of monomers. Okay, so that's what you do here. And now, oh man, Mr. Olkers is being just a real bad guy, okay? So now he says, describe your own examples of potential energy. Now, I haven't actually thought of something. Let me think. There's a guitar behind me. I'm going to draw that. Okay, so here we go, notes. Okay, here's a guitar hanging on the wall. How does that look? Okay, it's got a couple hooks. Here's the thing on the wall with the hooky thing and the hooky thing. And then here's a guitar. And this is what the guitar looks like on the wall, right? There's a guitar on the wall. And then here's the thing on the wall. And my kids ran through the room. And what do kids do? They destroy things. And here's the guitar on the ground. And guess what? They snapped the neck. Crack. Broken. Here's my broken guitar that my kids stepped on and ruined. Okay? And so now I'm going to say more energy, more PE. It's higher up, more PE, and also lost some of its strings broke. It also lost some of its elasticity on its strings. This is an example of gravitational potential energy gone wrong. Okay, I'm gonna do one more for you, just for kicks. What's something that has elasticity? Yoga pants. Nope, that could go sideways really quick. What's something else that has elasticity? Rubber bands. Okay, here we go. This is gonna be hard to draw. Okay, you guys better get better at drawing than me. Here we go. Oh, wait, no, there's another part to this. Okay, I'm not gonna do another one. I'm just gonna draw it over here. I got to outline it. Guitar on ground. Okay, guitar on ground, guitar on wall. All right, there you go. So the guitar on the wall, it takes energy to lift it up and put it on the wall. And then when it falls off the wall, because the kids bump it, it goes back on the ground. And this is the continual process of being a father. Your kids run around your house, knocking stuff. You never find everything put away. You know, you don't have your kids run through your house, especially like now they're a little bit older and more responsible and the house isn't as messy. When you have 5 children, when you have 5 kids under the age of 7, I think that was the life I had, 5 children under the age of 7, you don't go home at the end of the day from work and discover the kids put everything away and the house is clean. It's like Hurricane Katrina inside of your house every day. Everything came out of everywhere and it's all on the ground. It's on the floor. It's all lost all of its potential energy and it's on the ground now. And you just put the kids to bed and then you put it all away. That's what it is to be a parent of young children. Okay, that is your homework for the day. Have a great day. Peace out, Girl Scouts.